In this video, we will explore the properties of rectangles and use those properties to solve different kinds of problems. So what are the properties of rectangles? Well, first of all, let's not forget the properties of any parallelogram. A rectangle is just a special kind of parallelogram. So for all parallelograms, opposite sides are congruent. Okay, opposite angles are congruent. Okay, and consecutive angles are supplementary. All right, so like this angle and this angle would add up to 180 degrees. So that's true for any parallelogram. Now, there's something special. There are two special things for a rectangle. First of all, the definition of a rectangle is a quadrilateral that has four right angles, four 90-degree angles. So that's one thing that's special, is that all four angles of a rectangle will be 90 degrees. So that's the definition. The special property of a rectangle is that the diagonals will be congruent. So RC and ET will be congruent. All right, so looking at this picture, we're given some information. I've got an angle here, I've got a side. Let's see what we can figure out. Problem number one, we're supposed to find the length of AD. Okay, AD is this segment right here. Well, opposite sides of any parallelogram are congruent. So if BC is 12, then AD is also 12. Okay, what about CD? Okay, maybe I should leave these angles. So this is 12. CD, same thing. Since AB is 5, then CD is also 5. Opposite sides are congruent. All right, what about the measure of angle ABE? ABE. So that's this angle right here. What is this going to be? That is going to end up being 62 degrees. When you have a rectangle, these diagonals are forming isosceles triangles. So I don't know if you know this or not, but if you have an isosceles triangle, first of all, when I say the word isosceles triangle, it means that two of the sides are congruent. Now, if that's the case, then I've got two angles that are congruent as well. These are called the base angles. And the base angles of an isosceles triangle are always congruent. So this isosceles triangle is sort of rotated over on its side. But if these two sides are congruent, then these two base angles are congruent. So they both have to be 62. Okay, now how about the measure of angle BCA? Okay, let's see. Angle BCA is this angle right here. Now there are several ways I could find out what this angle is. So I paused the video to think about which way I wanted to do. Well, here's one way. I could look at the right triangle that I'm about to highlight for you now. Okay, because this is a rectangle, all of the angles are 90 degrees. So this is a right triangle. Okay, so if I've got a right triangle, then these two angles will be complementary. They have to add up to 90. So if I want to find this angle right here, I should be able to do 90 minus 62. Okay, if I do 90 minus 62, that's 28. Okay, so this is going to be 28 degrees. Next, we're supposed to find the length of segment BE. Well, here is BE, and here is segment ED. These are two halves of the same diagonal. So since ED is 6.5, then BE must also be 6.5. Next, we need to find AC. So here is AC. And the easiest thing to do is to compare this to the other diagonal, BD. All right, one of our special properties of a rectangle is that the diagonals are congruent. Both diagonals are the same length. So AC and BD should be the same length. Well, we just figured out that the two halves of BD are 6.5 and 6.5. If I add those together to find the total length of BD, okay, 6.5 plus 6.5 is 13. Okay, so the total length of BD is 13. So if one diagonal is 13, then the other diagonal is also 13. So AC is 13. Okay, how about the measure of angle EAD? Erase this. Okay, angle EAD. So that's this angle right here. Well, I'm hoping you can see that this angle from here to here is a right angle. That's 90 degrees. So these have to be complementary. So I can just subtract 62 from 90. So if I just do 90 minus 62, that's 28. So that means this angle right here must be 28 degrees. Okay? So that's 28 degrees. Now, what about angle CEB? Okay, CEB. Okay, well, now I am wishing that I didn't erase it earlier, but earlier I found the measure of angle BCA. Okay, angle BCA was this angle up here in the corner. So it will not be a surprise to you that this is also 28. These are actually alternate interior angles, the 28 and the 28. So of course they're equal. Okay, but now I am going to use that to find the measure, let me get this out of the way, to find the measure of this angle BEC. So first of all, understand that what I have here is an isosceles triangle. Okay, these two sides of the triangle are congruent. Okay, that means that the angle at B and the angle at C, those are my base angles. And the base angles of an isosceles triangle are congruent. So these are both 28 base angles. So they all have to add up to 180. So I'm just going to subtract from 180. So if I take 180 minus 28 minus 28, that's 124. So this must be 124 degrees. All right, on rectangle EFGH, EG is equal to this, FH is equal to that, and EF is equal to that. Sketch and label a picture. Make sure the vertices are in the correct order, like clockwise or counterclockwise. So, let's draw ourselves a rectangle. Okay. EFGH. So EFGH. When you label, just make sure you go around in a circle. Okay. Now EG. I'm going to change colors now. EG is 15y plus 10. Okay, so EG is a diagonal. Okay. FH is 18y minus 2. So that's the other diagonal. Okay, so let's see. So this diagonal is 18y minus 2. So this is 18y minus 2. Okay, great. And EF is 12y plus 6. All right, so great. I have everything labeled. Now, which two lengths must be the same? Highlight them. Write an equation. So, well, I drew them in color in the first place. So the red length and the blue length must be the same. Okay, so maybe I'll try to color coordinate these. So the 15y plus 10, okay, must equal the 18y minus 2. All right, now we'll solve the equation to find the value of y. All right, so I am going to subtract 18y from both sides, so minus 18y minus 18y. So that will give me negative 3y plus 10 is equal to negative 2. And I will subtract 10 from both sides, so negative 3y is equal to negative 12. So if you divide both sides by negative 3, you get y is equal to 4. All right, so we found the value of y. Substitute this value and find the lengths of EG and EH and EF. Okay, so let's see, EG should equal 15y plus 10. Okay, so EG should equal 15 times 4 plus 10. All right, so EG is equal to 70. Okay, so EG. Now FH, okay, FH is congruent to EG. They're both diagonals of the same rectangle, so they should be equal. So I don't need to work out an equation for this. I just know that FH will also equal 70. Okay, now what about EF? All right, for EF, I will use the expression 12y plus 6. All right, so it's going to be 12 times 4 plus 6. And that's 54. All right, problem number 12. This is a rectangle, all right? We're given that it's a rectangle. UZ is x plus 21. So that means that this is x plus 21. ZS is 3x minus 15. So this is 3x minus 15. For any parallelogram, the diagonals bisect each other. They cut each other in half. So these two sides of the diagonal should equal each other. So that means that 3x minus 15 should equal x plus 21. If I subtract x from both sides, that's going to give me 2x minus 15 is equal to 21. Then I would add 15 to both sides. So that will give me 2x is equal to 36. And if I divide both sides by 2, that will give me x is equal to 18. Okay, so now I need to find the length of US. Okay, so US is the entire diagonal. So US should be, look, let me start with finding UZ, because that's halfway. So I'm just going to find UZ, and then I'm going to double it. Okay, so let's start with UZ. UZ is x plus 21. All right, but x is 18, so that's 18 plus 21. So UZ is 39. Okay, now UZ is half of the diagonal. So US should be double this. All right, because US is the whole diagonal. All right, so x is equal to 18, and US is 78. All right, for number 13, we're given an expression for RZ, and we are given an expression for ZS. Okay, those should be congruent to each other. All right, they're both halves of a diagonal, and the diagonals are congruent. So the two halves should equal each other. So that's why I should be able to solve this by setting these equal to each other. So 6x minus 28 should equal 3x plus 8. So we're just going to solve this. So subtract 3x from both sides. So that'll give me 3x minus 28 is equal to 8. And then I would add 28 to both sides. So that'll give me 3x is equal to 36. If you divide both sides by 3, you get x is equal to 12. Okay, so now I need to use that to figure out what uz is equal to. All right, uz, well, uz is this over here. That's yet another half. All three of these are equal to each other. So if I find the value of any of them, then I found all of them. So let's see. Consider the yellow piece, RZ. I should be able to find RZ very easily because RZ is equal to the expression 3x plus 8. But now we know what x is. So this is going to become 3 times 12 plus 8. So RZ is 44. And if RZ is 44, that means all three of these little pieces are 44, including UZ. All right, number 14. We're given an expression for RT. And we are given an expression for RZ. Interesting. Okay. So I'm hoping you can see that RT is the whole diagonal and RZ is half. Okay. Maybe it would be better if I did it this way. Okay, RT is the whole. So this whole thing is 5x plus 8. On the other hand, RZ is just half of that. So that's the 4x plus 1. So here's what we're going to use. Hopefully it makes sense if I say 2 halves equal a whole. 2 halves equal a whole. Well, this is the half and this is the whole. So 2 halves equal the whole. So that's how you set it up. If I do the distributive property here, I'm going to have 8x plus 2 is equal to 5x plus 8. Subtract that 5x from both sides. I have 3x plus 2 is equal to 8. Subtract 2 from both sides. I give 3x is equal to 6. Divide by 3. I get x is equal to 2. So now I have x. Now I'm supposed to find zt. All right, zt is this piece right here. That's my target. I'm hoping you can see that zt and rz, these two halves are the same. So my strategy will be, first I'm going to find rz, and then whatever that is, that's going to be the answer for zt as well. Rz is 4x plus 1. Okay, that means that Rz, now that I know that x is 2, so this will be 4 times 2 plus 1. All right, that means that Rz is 8 plus 1. So RZ is 9. And if RZ is 9, that means ZT is also 9. Okay, because they are two halves of the same diagonal. All right, number 15. Aw shucks, we're given angles now. Angle SUT. So angle SUT is this angle right here. SUT. All right, so we're given this angle. All right, what else? Angle RUS. RUS is this angle right here. RUS. Okay, so we're given an expression for this angle as well. Now, these two angles have to be complementary. All right, this is a rectangle. All right, we're dealing with a rectangle, and the definition of a rectangle is all four angles have to be 90 degrees. So this angle, RUT, this is a 90-degree angle. So that means the two pieces, the two smaller angles, have to add up to 90. Okay? So that means the 3x plus 6 plus 5x minus 4, they have to add up to 90. So I'm just going to combine my like terms. 3x and 5x are like terms. 6x and negative 4 are like terms. So that's going to give me 8x plus 2 is equal to 90. Subtract 2 from both sides. So that's 8x is equal to 88. Divide both sides by 8. And you get x is equal to 11. All right, but now I'm supposed to find angle SUT. All right, well, angle SUT is the red angle. We have an expression for that. All right, the measure of angle SUT, right from the beginning, we were told that that is 3x plus 6. So the measure of angle SUT, now that I know x is 11, is going to be 3 times 11 plus 6. All right, that's 33 plus 6, so that's going to be 39. All right, last one. Angle SRT. All right, angle SRT is that angle right there. So we have an expression for that. Okay, how about angle UTR? Angle UTR is this angle right here. So how are these related to each other? These are alternate interior angles. Okay, do you see the Z that's formed? Well, it's kind of a backwards Z. All right, anytime you have a Z like this in a parallelogram, all right, these are alternate interior angles. All right, because think about it. All right, if we have the top and bottom of a Z, for a rectangle, these of course will be parallel lines. So if I put a line across like that, now I have parallel lines cut by a transversal. So that makes these alternate interior angles, and alternate interior angles are congruent if the lines are parallel. So I can set these angles equal to each other. So that's why I will know that 2x minus 44 should equal x plus 9. So I could subtract x from both sides. That will give me x minus 44 is equal to 9. And then I would add 44 to both sides. All right, so that'd be 44, 54, 53. Well, I shouldn't put a box around this. So this is not the final answer. X is 53, but now I need to find angle UTR. But I was given an expression for that right from the start. X is 53. So this is going to be 2 times 53 minus 44. That's 62. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.